Hi, my name is Cheong Jia Jun. My metric number is AN190182. I'm from UTHM, and this video is an assignment for the course BNM20104 Manufacturing Process Technology Section 1 to demonstrate the manufacturing processes by means of processing operation. In this video, I will discuss about heat treatment, which is a property enhancing process. Heat treatment is a controlled heating and cooling cycle intended to adjust the microstructures and mechanical properties of material for a specific purpose. In other cases, heat treatment is used to relieve the effect of strain hardening that occurs during forming, so that the material can be subjected to further deformation. Heat treatment can also be accomplished at or near the end of the sequence to achieve the final strength and hardness required in the finished product. The principal heat treatments are annealing, martensite formation in steel, precipitation hardening, and surface hardening. Most heat treatment operations are performed in furnaces. They usually heat the work part by a combination of radiation, convection, and conduction. Heating technology divides between fuel fire and electric heating. Fuel fire furnaces are normally direct fire, which means that the work is exposed directly to the combustion products. Electric furnaces use electric resistance for heating. They are cleaner, quieter, and provide more uniform heating. Now, I will show the process of heat treatment to form martensite in steel. Typical heat treatment of steel are alternatizing, quenching, and tempering. Alternatizing involving heating the steel to a sufficient high temperature that is converted entirely or partially to alternate. The steel must be held at the elevated temperature for a sufficient period of time to allow the new phase to form and the required homogeneity of composition to be achieved. Next, quenching step involves cooling the alternate rapidly enough to avoid passing through the nose of the TTT curve as indicated in the cooling trajectory. The TTT curve showing the transformation of alternate into other phases as a function of time and temperature for a composition of about 0.80% carbon steel. The cooling trajectory shown here yield martensite. Whereas quenching media are used in commercial heat treatment practice, there are brine salt water, usually agitated, freshwater steel, not agitated, steel oil, and air. In addition, martensite is hard and brittle. Tempering is a heat treatment applied to hardened steel to reduce brittleness, increase ductility and toughness, and relieve stresses in the martensite structure. It involves heating and soaking at a temperature below the alternatizing level for about 1 hour, followed by slow cooling. This results in precipitation of very fine carbide particles from martensite iron carbon solution and gradually transform the crystal structure from BCT to BCC. This new structure is called tempered martensite. A slight reduction in strength and hardness accompanies the improvement in ductility and toughness. Martensite is a hard, brittle phase that gives steel its unique ability to be strengthened to very high level. The extreme hardness of martensite results from the lattice strain created by carbon atom trapped in BCT structure, thus providing a barrier to slip. From this figure, we know that the significant effect that the martensite transformation has on the hardness of steel for increasing carbon content. Martensitic stainless steel is a good choice for a variety of applications because of its durability, strength, and corrosion resistance. The composition and properties of martensitic steel give it advantage over other types of steel in various industrial functions. This treatment makes martensitic steel an ideal option when manufacturing mechanical valve and instrument, turbine part, medical instrument, and other applications and products. That's all from me. Thank you.